Day 5, Human Activity Recognition using Smartphones Dataset with Random Forest. This project will classify human activities like walking, sitting, standing, etc. based on the sensor data from the smartphones. We will use the Human Activity Recognition, which is HAR, dataset from UCI, which contains data from accelerometers and gyroscopes in smartphones. The project will use random forest as the classifier. So let's start with the project. So first I need the dataset. So I'm going to go again to Kaggle and look for the UCI dataset of human activity recognition with smartphones. I'm going to download it from here. So let's open the dataset here. I have two different ones. I'm just going to take the trained one because that's bigger, and I am just going to change that. I can merge both of them and create one, but I'll just use one of them as hard data set. I'm going to take this and move this to my online training, harddata.csv. Remember that. Go back here and create a new file, call it day5.python. Now our first step is to import the required libraries. So I'm going to say import required libraries. And here, first one that I need is pandas. Now pandas is used for loading and manipulating the dataset. So I'm going to say import pandas as PD. Next, I need the train test split, which splits the dataset into training and test sets. So I am going to say from sklearn dot model selection import train test split. Next I need is the random forest classifier. Now that comes from sklearn ensemble. So I am going to say sklearn dot ensemble import. I want random forest classifier. This is the classifier that will be used for human activity recognition. And next I need my metrics. So I'm going to say sklearn dot metrics import. I'll do all of them. Confusion matrix, I'll need accuracy score, I need precision score. Since I've already done before, that's why it automatically populates and gives me better intelligence here, F1 score. So that's good. Next I need seaborn, import seaborn as SNS, and this one is used to create a heat map from the confusion matrix visualization. And then I need import matplotlib dot pyplot as plt, and this is for plotting the confusion matrix. So let's go ahead and first let's load the data set. So I'm going to say here I'm going to load the data set which I got from that URL df equal to. Now for future reference, if you want to use this, I am going to keep this URL in this document, so you have that data. And here I am going to say df equal to pd dot read underscore csv, and the file is har underscore data dot csv. So I have loaded my data set here. So this particular function, it loads the human activity recognition, which are HAR dataset. The dataset contains sensor data from accelerometer and gyroscope, and corresponding activity labels. We'll have like walking, sitting, standing, all that stuff inside this dataset. Now let's go ahead and pre-process the dataset. For that, I will first say pre-process the data set, and for that I'll first drop the fields that I don't need, drop the column that I don't need, which is the activity on the axis equal to 1. So I have all my features in this particular. So it removes the activity column from the data set, leaving only the features which are the sensor readings. And then I need the y equal to df, and inside that I'll only have activity. So this will be the target variable, contains the activity labels, example walking, sitting, and standing. So if I want to go and check this out data set here, you'll see it has all these different data items here inside this, and my last column here is activity, and that's what is my target variable. So that's what I've set here. So perfect. Once this is done, I'm going to let's say split the data set into training and testing sets. Now that I can do using x underscore train, x underscore test, y underscore train, y underscore test, something similar that we did in yesterday's video. Test underscore split, and here I'll need x y test size equal to 0.2 and my random underscore state equal to 42. Now if you've not seen yesterday's video, what this does is it makes sure it splits the data set into training and testing sets, and 80% of the data is used for training and 20% of the data is testing. The random state 42 ensures reproducibility of the split. And now next step will be to train the random forest, let's say to train the random forest classifier. And that I can do first. I'll create a model object, a model variable, which I will say random forest classifier, and to it I'll assign two different parameters. One is n estimators, uh, which initializes, so this kind of initializes the random forest classifier with 100 trees. So n estimators will be the trees. I'm going to say 100, and then random state equal to 42. The random forest is an ensemble method that uses multiple decision trees for classification. That's why we have provided the 100 value to it. And then finally, I'll fit this model by saying model dot fit, and then to this I'll give x underscore train and y underscore train. I'll give the features and the labels to it. So this trains the random forest model on the training data, x train and y train. Next thing is I have to make the predictions. So for that, so let's move it to the top, and then I will say y underscore pred equal to model dot predict, and inside that I'll pay x underscore test. So this will give me my predictions, and now let's evaluate the model using, so I'll say, let's also say here, make predictions on the test set, and here I will say evaluate the model using accuracy. What all do we have? Precision, we have recall, and we have F1 score. So we'll say accuracy equal to accuracy score, and it knows what I need. Does it know y test and y red? Perfect. I can do the same thing for precision equal to precision score y test and y red. Next I'll do for recall, I'll say recall equal to recall score, give it y test and y pred. Perfect. Next I need to do f1 equal to f1 score, and then inside that y test and y pred. Perfect. So that in place, I'll print it out. I can say print f accuracy is accuracy, and I can like last time we didn't do this, but I can multiply this by 100 and say point to f, so I have a better percentage. You can do this for all of them, but I'm just going to keep it for one, or I can just say this. So I have my accuracy, I have my precision, I have my what was the other thing, recall, and I have my f1 underscore score. This is f1, this is recall, this is precision. So I'm going to print all these out. So visualize the confusion matrix using Seaborn's heat map. CM equal to confusion matrix, and to that I'll pass that y-test and y-pred. And then for the heat map, I'll say heat map, call the heat map function, pass the confusion matrix, say annotate equal to true. I want it to annotate. Next, I want to use integers only, so I'm going to say decimal values. And then for colors, this time I'll give a little bit different colors. I'll say blues as compared to last time. And plot dot title confusion matrix, matrix, and then I'll say plot dot show. Let's see if it's right. Yep, looks everything is perfect in place. I'm going to go back to my command prompt and let's make sure we're in the right place. Yes, we are. And then say python day5.py. Run it. Looks like I have a typo here. Instead of random, I said random. So let's make sure that is fixed and fixed here. So let's go back, clear it out, run it again. And there you go. We have our predictions out here where it shows the confusion matrix over all the different values that we have depending on setting, standing. So all these different things are coded out here where we have six different elements here, as you can see, and it shows our confusion matrix. If you had any issues or problems while following along, let me know and I'll get back to you. Thank you.